Okay, so we were discussing localized vectors and free vectors. We are not using localized vectors in this chapter. We are dealing with the free vectors only. Okay, we are dealing with the free vectors. So this vector, this vector, this vector, this vector, this vector, all are having a similar line of support. You see, this is the line of support. Line of support, this is the line of support, this is the line of support, all are parallel, and their magnitude, their length are also equal. So all are same vectors. Okay, they are same vectors. Okay, this is a 5 I cap here, this is also same direction 5 I cap, both are same. Okay, that is free vectors. I hope you understood. Clear? Now what is next? Co-initial vector. Co-initial vector. What is co-initial vectors? Vectors, 2 or 3 vectors having same initial point. Very simple. This is OA, this is OB, this is OC, etc. So I can say OA, OB, OC are co-initial vectors. Okay. Now what is co-terminal vectors? Co-terminal vectors. This is also very easy. They are terminal points. Say this is O, this is AO, BO, CO. So AO, BO, CO are called co-terminal vectors. Okay, same terminal points. Okay, that's the definition. These are just basic definitions, very easy also. Okay, now equal vectors. What is equal vectors? 2 vectors are equal if they have same direction and same magnitude. Okay, so this is vector A, this is vector B. Their directions are same? Yes. As I said, we are dealing with the free vectors. Okay, we are dealing with the free vectors. So their directions are same and magnitude also same. Same magnitude and same direction. Don't think that its direction is here, sir. It is here, but here it is here. No, we can move this here. You can move vectors. You are free to move the vectors. This vector can be moved here and wrote like this. Can be written like that. So it's not a problem. Both are same. We are dealing with the free vectors. Okay. So equal vectors are 2 vectors. They have the same magnitude and same direction. Okay. So that's the case here. This is then we can write vector A equal to vector B. Clear? Next is negative of a vector. Negative of a vector. What is negative of a vector? Very simple. Negative of vector A is denoted by minus A. Now what is its meaning? It have the same direction? No. We have the opposite direction. Okay, opposite direction and same magnitude. Okay, opposite direction and same magnitude. I can also say that AB, its negative will be minus of AB, and minus of AB can be written as BA. So what is negative of AB? I can say minus AB or I can say BA. Okay, clear? And if I add AB and its negative, what will I get? 0. If I add A and minus A, what will I get? 0 vector. Okay, not 0 vector. That's the negative of a vector. Clear? Okay, next one, collinear vectors, also known as parallel vectors. What is collinear vectors? Two vectors A and B are collinear if they have or if their lines of support are parallel. That's the logic. Vector A, vector B. What is its line of support? Its line of support is like this one. Its line of support is this. Are they parallel? Yes. Okay, so they are parallel vectors. Or I can say vector A and another vector, say C. They have the same direction? No, but opposite direction. But lines of supports are parallel. So that's the case. In this first case is called like vectors. So what do you mean by like vectors? Same direction. What is unlike vectors? Unlike vectors means not same direction. No, that's not the definition. Opposite direction. So two vectors A and B are said to be like vectors if they are collinear vectors and also their directions are same. Okay, so two parallel vectors whose directions are same are called like vectors. Two parallel vectors whose directions are opposite are called unlike vector. Two vectors which are like vectors and magnitude same, then both will be equal. Okay, clear? So that is collinear vectors or parallel vectors, or in that we can split it into two: like vectors same direction, unlike vectors opposite direction. Okay, and one more thing is, if A and B are parallel or collinear vectors, then B can be written as lambda A or A can be written as lambda B, where lambda is a scalar. Okay, that's very important. If A and B are collinear vectors, I can write B equal to lambda A. Clear? If A equal to A1 I cap, A2 j cap, A3 k cap, and B equal to B1 I cap, B2 j cap, B3 k cap. Okay, then A and B are collinear, then I can write A1 by B1 equal to A2 by B2 equal to A3 by B3. Clear? A1 by A2 equal to A2 by B2 equal to A3 by B3. So that is collinear vectors or parallel vectors. Okay, if lambda positive, what will happen? If lambda positive, these two vectors are like. If lambda is negative, they are unlike vectors. Okay, vectors. Clear? So that's the case.